Hi guys, so today we're going to be doing proving angle relationships. Before we get started with the example, let's look at some of our postulates and theorems from this lesson. Okay. So the first one is the protractor postulate. Given a ray AB and a number r between 0 and 180, there's exactly one ray with endpoint A extending on either side of ray AB, such that the measure of the angle formed is whatever r is. Okay. Not a common one, but just one that your book wanted you to know. Angle addition postulate, that's similar to what we did previously with segment addition postulate. Okay. But basically, if R, the point, is in the interior, is inside angle PQS, then we know that the measure of angle PQR plus the measure of angle RQS would equal that bigger angle here, PQS. Okay? And then the converse of it is true, right? So if the measure of angle PQR and the measure of angle RQS is PQS, that means R is in the interior of that angle. Then we have the supplement theorem. If two angles form a linear pair, then they are supplementary angles. Oftentimes, I would just hear this as linear pair postulate rather than supplement theorem. Right? But if two angles form a linear pair, then they're supplementary angles. I normally hear that as linear pair postulate. Okay, and then a complement theorem is if the non-common sides of two adjacent angles, so in that case, that would be this one right here. If this one here. These two here. If the non-common sides of two adjacent angles form a right angle, then these two angles are complementary. They add up to 90 degrees. Right? Here, it just tells us that we can apply the reflexive property, symmetric property, and transitive property to angles. Right? And then continuing on page 126, angles that are supplementary to the same angle or to congruent angles are going to be congruent. Okay? Angles that are complementary to the same angle or complementary to congruent angles are going to be congruent. Okay? And then last one here is the vertical angle congruence theorem. It just tells you that vertical angles are congruent. Okay? And there we go. Okay? And then here are some right angle theorems. Perpendicular lines form four right angles. All right angles are congruent. Perpendicular lines form congruent adjacent angles. That the reason why is because of those, they form right angles, and all right angles are congruent. If two angles are congruent and supplementary, then each angle is a right angle. Right? They would have to both be 90 in order to add up to 180. Okay? And then if two congruent angles form a linear pair, right, then they have to be right angles as well, because they have to be congruent and add up to 180 for the linear pair. So they both have to be 90. Okay, so let's get started with example 1. Okay. The Grand Union flag at the left, it's actually here on the right, contains several angles. If the measure of angle ABD here is 44, and the measure of angle ABC is 88, what would DBC be? Okay, so it's a little bit hard to see here, but basically the picture looks something like this. Okay, so A, B, D, C. So here we know the measure of angle ABD is 44, so I would write 44 here. And then ABC, the whole thing is 88. What would DBC have to be? Okay. So what we should know from the angle addition postulate is that the measure of angle ABD, this here, plus the measure of angle DBC, this one here, should equal the bigger angle here, ABC. Okay. If this was a proof and I had to explain why, this is the angle addition postulate. Okay. Since we know angle ABD is 44, I can replace this with 44 degrees. Since I know that ABC is 88, I can replace that with 88 degrees. If I was doing a proof, the reason I can say all of this is the substitution property. Okay. Then, to get angle DBC by itself, I just need to subtract 44 on both sides. And that gives me 44 degrees. Okay. And the reason why I can do that is because of the subtraction property of equality. Okay. But there you go. So why don't you try check your progress 1, and then once you're done, come check your answer. Okay, this is the type of work and thinking you should have gone through. Measure of angle NKL is 56 degrees. Okay. So we know that measure of angle JKN is 56, and we know that measure of JKL, the total here, is 2 JKNs. Okay. So what I did is I replaced the measure of angle JKN with 56 degrees. That is due to the substitution property of equality. Okay. Then I just simplified. 2 times 56 is 112, so this, my reasoning would just be simplified. Okay. Then, angle JKN here plus angle NKL here should equal the bigger angle here, JKL. Okay. That is because of the angle addition postulate. Okay. Then, since I know that JKN is 56, that was given to me, and JKL I just solved was 112, I can substitute it in. And then lastly, to get measure of angle NKL by itself, I would subtract 56 on both sides. Okay. And then I would get measure of angle NKL is 56 degrees. And this is because of the subtraction property of equality. Okay. Okay. So next here, if angle 1 and angle 2 here form a linear pair and measure of angle 2 is 67 degrees, we want to find the measure of angle 1. Okay. So first thing, if they form a linear pair, their angle measures should add up to 180. Okay. And the reason for that is because of the linear pair postulates. Linear pairs add up to 180. Then I know the measure of angle 2 is 67, so I can substitute it in. Okay, so this is the substitution property of equality. And then to get angle 1 by itself, I'm going to subtract 67 on both sides. And that gives me 113. That's the subtraction property of equality. And there I found the measure of angle 1. So why don't you try 2A and 2B on your own using this picture, and then come check your answer. Okay, so for 2A, measure of angle 3 is 50, measure of angle 4 is 70, and measure of angle 5 is 60. Okay. For 2B, x equals 17, measure of angle 6 is 83, and measure of angle 7 is 97. If you got them all correct, you can move on to the next section. If not, here is your explanation. Okay. So here we're talking about angle 3, 4, and 5. They are a linear triple. Okay. So the angle measures of all three, the sum of them equals 180. Okay. Then I just substituted what each of them were. So measure of angle 3 was substituted with x plus 20, angle 4 is x plus 40, and angle 5 is x plus 30. That was all given to me. Okay. Then I just combined like terms, so x is 3x, 20 plus 40 plus 30 is 90. Okay, so then I just simplified, so my reasoning would be simplified. Okay. Then I subtract 90 on both sides, get 3x equals 90 due to the subtraction property of equality. And then divided by 3 on both sides to get x equals 30 due to the division property of equality. Okay. Now, since I know what x is, I can substitute x in with 30. So that's why it's 30 plus 20, or 3 to get 50. 30 plus 40 to get angle 4, that's 70. And then 30 plus 30, which is 60 to get angle 5. Okay. For 2b here, I'm told that angles 6 and 7 are a linear pair, so they should add up to 180. Then I substituted angle 6 with the 3x plus 32 and angle 7 with the 5x plus 12. Then 3x plus 5x is 8x, and 32 plus 12 is 44. The reasoning is I just simplified or combined like terms. Okay. Then I got rid of the plus 44 by subtracting on both sides. I got 8x equals 136 due to the subtraction property of equality. And then divided 8 on both sides, x equals 17 due to the division property of equality. Now that I know that x is 17, I can substitute it in for x. So for 6, it'll be 3 times 17 plus 32, which is 83. And then for angle 7, it's 5 times 17 plus 12, which is 97. Okay, so next we're moving on to example 3. Okay, so here in the figure, angle 1 and 2 form a linear pair, and angle 2 and 3 form a linear pair. We want to prove that angle 1 and angle 3 are congruent. So this here is our proof for the vertical angle congruence theorem. Okay, so let's write our 2-column proof with statement and reason. So statement and reason. Okay. So starting with what I'm given, angle 1 and angle 2 form a linear pair. And angle 2 and angle 3 form a linear pair. I'm going to run out of space. Okay. And then my reason I can say that is because that was given to me. Okay. Then 2, what I know then is angle 1 and 2 are supplementary. And angle 2 and angle 3 are supplementary. And then the reason why is because of that supplement theorem. And the supplement theorem tells us that angles that are supplementary to the same angle, in this case angle 1 and 3, are supplementary to the same angle. Angle 2, well, what we'll then know is that they're going to be supplement to each other. So here they wrote supplement theorem. Another way I actually probably would have written this is our linear pair postulate. Because our linear pair postulate tells us that it adds up to 180. So rather than saying supplement theorem, I would probably write linear pair postulate. Okay, and then lastly, angle 1 is congruent to angle 3, and that is what I said earlier, that angles supplementary to the same angle are congruent. Angle are congruent. Okay. And that you saw, they called it 2-6, but again, that means nothing, so you better write out what it means. But here, angles supplementary to the same angle or to congruent angles are congruent. Okay. And since they're both supplementary to 2, that means they both have to be congruent. Okay. So I'm going to have you try check your progress 3 and then come check your answer. Okay, so here's number 3. There's many ways to prove it. So I just wanted to show you that with these two different proofs that still prove that angle ABD is congruent to angle EBC. So the one in black is given by the book, and then the one in red is actually kind of how I think of it and how I would have proved it. It does seem a little bit longer, but I feel like it's less complex, even though it looks quite complex here. Okay, so I'll just go over both, and then we'll continue on. Okay, so here for the book one, we started the same way with our given, where the measure of angle ABE is 90 and the measure of angle DBC is 90, and the reason why is because that was given to us, that was right angles. Okay. Then for their step two, they said that angle ABD and DBE are complementary. Okay. And angle DBE and EBC are complementary. And then they used the complements theorem for that. Right? That if the non-common sides of two adjacent angles form a right angle, then the angles are complementary. So that's the complementary theorem. Okay? And then they stated that ABD is congruent to EBC because angles that are complementary to the same angle, right, they're both complementary to angle DBE, then those angles have to be congruent. Right? So that was theirs. Okay? That one requires that you remember the complementary theorem as well as this theorem, versus my way is a little bit more algebraic. Okay? So my given starts the same way. So our statement one is the same because we're both starting with the given. Okay. And then for me, I thought of it as, oh, ABD and DBE form ABE. And DBE and EBC form DBC. That's the angle addition postulate. Okay. Then I wrote that those big angles, ABE and DBC, are congruent or equal here. The measures are equal because they're both right angles and all right angles are congruent. Then I combine step 2 and 3 by substituting ABE with what it's composed of, ABD and DBE. And I replaced DBC or substituted DBC with what it's composed of, the DBE and EBC. Okay, so that's the substitution property of equality. Okay, and then because they both have the angle DBE, I now subtracted it from both sides, leaving me with just ABD and EBC. And that was due to the subtraction property of equality. And if their measures are the same, that means the angles are congruent because that's the definition of congruent angles. Okay, so both of them work. I'm sure someone else can think of another way of how this could work, but this is just two examples of how we can have the same given and prove the same thing in different ways. Okay. So our last example is example 4 here, which is vertical angles. So here we're told that angle 1 and angle 2 are vertical angles. Measure of angle 1 is x, and the measure of angle 2 is 228 minus 3x. We want to find the measure of angle 1 and measure of angle 2. Okay, so if they're vertical angles, what we should know is that their angle measure should be the same, and that is because of the vertical angle congruence theorem. Okay. So if their measures are the same, now I'm going to substitute angle 1 with x, and I'm going to substitute angle 2 with 228 minus 3x. Okay. If I had to give a reasoning, the reasoning would be the substitution property of equality. Okay. Next, I'm going to move the 3x to the other side by adding it. That will give me 4x equals 228. Reason for that is the addition property of equality. I added 3x to both sides. Okay. And then the last part, to get x by itself, I'm going to divide by 4 on both sides using the division property of equality, and x equals 57. Okay. Now that I know that x equals 57, I can substitute it in. So for the measure of angle 1, which is just x, it should be 57 degrees. Okay. Measure of angle 2, I should know should be the same, but let's just check to make sure our math was correct by substituting 57 here for x. So 228 minus 3 times 57. 3 times 57 is 177. And 228 minus that is 57. I was correct. Both of them are 57 degrees. They should be equal because they are vertical angles and they are congruent. Okay. So why don't you check your progress 4 and then come check your answer. Okay, you should have gotten 50 degrees for both. If you got it right, you can move on to your homework. If not, here's your explanation. So because Angle 3 and 4 are both vertical angles. Their measures should be the same. They should equal each other. Okay? So the measure of angle 3 is 6x plus 2. Measure of angle 4 is 8x minus 14. Set them equal to each other. I substitute it in. Okay? Subtract 6x on both sides with the subtraction property of equality. So that's 2 equals 2x minus 14. Add 14 to both sides with the addition property of equality. That gives me 16 equals 2x. Divide by 2 on both sides using division property of equality. That's x equals 8. Okay. Now that I know x equals 8, I can plug that in for my x. 6 times 8 is 48, plus 2 is 50. 8 times 8 is 64. 64 minus 14 is 50. So angle 3 and 4 are both 50, which is correct because they should be the same since they're vertical angles. Okay? That's it for today. Have a great rest of the day. Bye, guys.